Welcome. I think class part 2, class number 35, I think. Now, you make a very important note. We are going to start finding support reactions for beams. The purpose is later when you go to SFD BMD and also later in structural analysis, when you require the support reactions, you should fluently get it without any doubt. Therefore, remember what I am going to tell now, everything, if I write on the board, you have to copy, or if I dictate also, you have to copy. Okay, first, we will consider a beam. A beam, AB. See, AB, don't by heart AB. A is left hand. See, this all I am not writing here. A is left hand, B is right hand. There can be overhang. Not 1 minute, before that one. Let there be supports at A and B. So you consider a beam AB which is supported at A and B. A is left hand, B is right hand. There can be overhang, but it will come later. Right now we are considering a beam supported at the ends, left hand and right hand. That's all. Now consider a horizontal beam. I told horizontal beam AB subjected to only vertical loading, or with or without couples. Means you should write vertical loading, okay, any loading, point load, UD, either point load or distributed load. Distributed load, all told for you, can be UDL, can be UVL represented by a triangle, or can be UVL represented by a trapezium. Then there can be couples. But remember, no horizontal loads right now. Class, I will tell you, write everything I dictate now. Why no horizontal loads? When you draw SFD and BMD, you do not require horizontal forces and horizontal reactions. If it is there, we can calculate, but later it is not considered. Therefore, right now, later, you write a note here. Later, I will consider the questions with horizontal loads also. That is general loading. But I want first some standard cases or very important cases. Only vertical loading with or without couple. First I will take loading and then I will take couples. So these all you write here. Now, let the beam be supported by a hinged support at left hand A and by a roller support at right hand B. Roller support, something I am telling in the class. And or let the beam be supported by a hinged support at B and roller support at A as shown. Again for roller support, something I am telling in the class. You should write it. This roller is in, I told this class. You write somewhere. The roller support he mentioned right now. See, roller support can be either like this or can be like this. Some truss problems you get it, or it can be inclined. Okay, but right now for our discussion, that is what we are considering right now, our roller support is in horizontal plane. Make a note. The roller support we are going to consider is in horizontal plane. That is here what roller you are considering is like this. Is like this. Okay, make a note. Now some state or, one or, I write here, or one more case, or simply let the beam, I forgot right, let the beam, okay. Let the beam be simply supported at both ends A and B as shown. See, some random loading, it is not this zigzag loading, some random vertical loading with or without couple. See, couple can be there, may be there or may not be there. Okay, leave it. Now, some statement you write outside. So after writing all these, you put one line there. So actually here, some space you have to leave, some space you have to leave, some space you have to leave. Then somewhere outside right, we already know hinged support has got vertical reaction and horizontal reaction. Roller support has reaction perpendicular to plane of the roller. If the roller plane is horizontal, that reaction R at roller will become V. Whereas simple support will have only vertical reaction. Therefore, right here, some statement you write here. For this beam, see, for this beam, you write here, after statement all, after statement all, after statement. For this beam, I will dictate now A, B. 1 minute. Here also, here roller hinge is there. Hinge there, roller here, A, B. Here simply supported, A and B. Okay. With the loading, show the loading. Random loading with or without couple. This, see, those who are serious should understand each and everything. Loading with or without couple. Now, for this beam, I will put a statement here now. There is no space to write, that much you should write. A is hinged support. There will be a vertical reaction at A, we will consider to be upwards. There will be a horizontal reaction at A, we will consider to right side. Okay, right now, HA. Here, there is a vertical reaction here, so not vertical, reaction normal to the plane of the roller, that is reaction RB, but since this roller is horizontal plane, that reaction is vertical, so I can call VB. Here, right, B is hinged support. There is a vertical reaction here, VB, horizontal reaction here, HB, and here reaction normal to plane of the roller, RA equal to VA. Here, right, after statement, since both are simple support, only vertical reaction VA, only vertical reaction VB. Actually, remember, you write for these two beams, horizontal loads are permitted. If you apply horizontal loads, this hinged support will give reaction to balance it. But this beam, horizontal loads are not permitted. This beam is unstable for horizontal load, or for that matter, right, once again, right now we are not bothered about horizontal reaction and horizontal loads. Right now our main purpose is vertical reaction for simply supported beam. Simply supported means, this is, some people call this simply supported. Actually, technically, so many people have seen, they tell simply supported beam, they will tell, and they will put one hinge, one roller. I will tell them, why you are calling this simply supported beam? The two supports are different types. They will tell, no, both has got vertical reaction. Then why don't you tell beam is simply supported at both ends? One person asked me answer, sir, okay sir, if I tell that way, suppose they apply horizontal load, it is not stable. Okay, if you talk that way, I will tell him one more thing. In that case, I will tell, you put a beam like this, correct? You show a beam like this. See, everything, if someone, what I tell, if somebody objects something like that, I will give an answer. I will tell, by chance for this beam, if you apply a load like this way, what will happen? Sir, it will rotate like this. Oh, is it stable? It is not stable. Then don't use the word stability all here. You simply tell simply supported beam. Therefore, now onwards, after little time I will tell you, I will call simply supported beam is this one. Now, make a note. If I am make a note, big note here. I am discussing the case of only vertical loading with or without couple. No horizontal load. Therefore, for this beam, if you apply sigma h equal to 0, you will get HA equal to 0. Here, if you apply sigma h equal to 0, you will get HB equal to 0. And here, there is no HAHB. Therefore, finally, what you got for this beam is right here. VA, VB, VA, VB, VA, VB. Therefore, if there is no horizontal, even if horizontal load is there also, you get the HA. Then once again it becomes same VA, VB only. See, even if some horizontal load is there, sigma H0 will give the value of HA. Then again unknowns are VA, VB. Therefore, instead of wasting time every time telling one hinge, one roller, at the hinged support, mark a horizontal reaction, then you write sigma H equal to 0, write that horizontal reaction equal to 0 to save the time. Therefore, this beam, and this beam, all three are same. All three are same. If we are interested, if the beam is loaded, if the beam is subjected to only vertical loading and couples, and we are interested in finding vertical reactions only, that is what you require for SFD BMD and later in so many structural analysis problems. So make this note. Therefore, when I start my example, one question, I will put hinge and roller. Next question onwards, I will write simply supported beam. I will always show this beam. Okay, I will now start one standard order. I will start. In the support reaction part, I had decided to put serial number 1, 1, 2, maybe 100 like that. Keep on putting number. I may in between change the statement. Now we are going for cantilevers, etc. Or I will do one thing now. For simply support beam with vertical loading and couples, I will start serial number 1, 2, 3, 4. Later when I change the question, I will once again put new numbers. Okay, start. 1. 1 means question 1. Now I won't waste time on these things. Question 1. First, beam, consider a beam supported by beam of supported, consider a beam, or some statement problem here. Okay, right. Consider a beam, okay, right here now. Okay. I'll write once again. Consider a beam, horizontal beam only, beam of length L, with supported hinge support, with hinged support at one end and supported by a roller support at other end. With the hinged support at one end and supported by a roller support at the other end, subjected to a central constant load. You can make a note. What you are covering is simply support. Heading you write. In the notes I will write it. Simply supported beam with the central point concentrated load. Now onwards, to save time, concentrated load takes more time. I will tell a point load. A point load W. Capital W, not small w. I usually use capital W for magnitude of the point load, small w for intensity. Sometimes people call P. Okay, P or W. Okay. At center. So beam, let A be hinged, B be roller, length L. W, center means L by 2. I will take the point as C. Okay, this is a beam. Or, question is, a simply supported beam of length or span, both are same, L, subjected to a constant load W at center, A, B, W, L. Both are same questions. Okay, now, only for first question, right? Or forgot something, okay. See, here something forgotten. Okay. Okay, start. Class A, hinged support, vertical reaction VA, horizontal reaction HA, unwanted. B, roller support, perpendicular reaction RB equal to VB. Here, class, both are simply supported, only vertical reaction VA and VB. Now, this question, right now, you throw out that HA, unwanted part. Sigma H equal to 0 will give HA equal to 0. So now, your HA is gone. HA is gone. Here, First of all, HA itself is not there. Now both the questions we are left with only VA and VB. Okay, start. I told all basic condition of static equilibrium, sigma H already over. Now we are left with sigma M0, sigma V0. Sigma H0 for this one already applied. For this one, sigma H0 is not applicable. This all I told you. Okay, start. See, first question, write everything. Now for both the beams, see this statement what I am writing is for this beam and also for this beam. See, this is for both the beams. Next time onwards, only this type. I won't waste time on this HA all. Why unnecessary waste time? See, start. First, apply sigma m equal to 0. I told already last time. When you take moment about one of the point where unknown is there. You can take moment about A or moment about B. I will take A. Okay. Finger should be at A. Clockwise positive. Now, those who are serious, at least for a few questions, write here. Not this way. In the notes, I will write at least for 5-6 questions. Here I decided not to write. Dictate. Algebraic sum of moments of the entire force system, that is, consider the full beam with action and reaction about any point is 0, but here about the point A is 0, or algebraic sum of moments of the entire force system, or beam, the beam in equilibrium, or beam with action and reaction. Now onwards I will call algebraic sum of moments of entire not required, simply algebraic sum of moments about A equal to 0. I will take clockwise positive. Okay, take moment about A here. When I take moment about A, I told already VA into 0, don't write it. I already told you, when you take moment about A, you will get other side reaction. So, VB into L, anti-clockwise. Here also, see, VB into L, anti-clockwise. So, minus, plus clockwise. W into L by 2, there also W into L by 2. So, now both are same beams, equal to 0. See now, when you simplify, L and L will cancel. Now, minus VB, you should be very careful, plus W by 2 equal to 0. So, minus VB equal to minus W by 2, or VB equal to plus W by 2, or this minus VB, you take that side. So, VB equal to W by 2, plus W by 2. Positive sign indicates that assumed direction is correct. Okay, now, sigma V0, take upward positive. Right here, statement, algebraic sum of vertical components of all the forces, entire force system equal to 0, plus VA plus VB minus W equal to 0. Same thing there also. Substitute VB equal to W by 2. You get VA plus W by 2 minus W equal to 0, or VA equal to, see, minus W goes that side as plus W. This is high school mathematics. That much you have to do. So, W that side minus W by 2, W minus W by 2, 1 minus half is half, VA will come plus W by 2. Okay, now write an answer. Therefore, see, answer, see. This answer will write every time. Therefore, you can write here. You sketch the beam once again, write final answer. Final answer. For this beam, this is A, this is B. There is a vertical reaction here, VB equal to W by 2. There is a vertical reaction here, VA equal to W by 2 upwards, no horizontal reaction, over. Or here, write one more sketch, right here. There is a vertical reaction VA here equal to W by 2, vertical reaction VB here equal to W by 2. You write all these, you first write, answer, neatly enter. This is the final result we got. This you should preserve it. Final result we got. Now make a very important note. Correctly observe. See both the cases. Central load W. Two reactions. Right here. This beam, I will dictate something here. Actually, for this beam, you need not apply sigma m0, sigma v0 because this is a case of, I told you, perfect symmetry. See, someone will tell, sorry, hinge and roller here. Okay, if hinge and roller here, now hinge is gone. Horizontal reaction is not there. We are left with only vertical reaction. So, it is only one reaction. This is a case of perfect symmetry. So, in case of perfect symmetry, whatever loading you apply on the beam will be distributed or transferred to support, equally will be transferred to support, or whatever load you apply, half the reaction at both support will be equal to half of the total load. Or right here, very important, right, due to symmetry, that is, you need not write sigma m0, sigma v0. This question, direct solution, see, direct solution, this question, direct solution, due to perfect symmetry, that is important, due to perfect symmetry, vertical reaction at A equal to vertical reaction at B equal to total load on beam, but symmetry not there, you can't apply, beam divided by 2, half equal to total load on beam is W, only one load, divided by 2 is the answer. VA in the upward direction, VB upward direction, total load is downward direction. See, for equilibrium, loading is downward, reaction is upward. So, VA in upward direction equal to VB in upward direction equal to total load on the beam, total downward load on the beam divided by 2 right here. This case is closed. Okay, now I will go to question 2 because next question is very, very powerful question. Some talkings are there. So I will just do one thing. I will give question 2 very fast. See, I will write here only question 2. I will dictate the question for you. Now onwards, I will not waste time writing everything, hinged support, roller support, not required, simply supported. Right. I will dictate the question. A simply supported beam of span 6 meter is loaded by a central concentrated load of magnitude 80 kilonewton. Find reactions at both the supports is the question. Right, correct? Okay, right. First, sketch the beam. This is the beam. Always remember, first always you write given beam. Make a practice in future. Do not write anything on the question. See, span is 6 meter, a load of 80 kilonewton. They told central load, this point is C. If it is 6 meter, this will be 3 meter. Okay. Now put the beam. Right now, first statement. Both are simple support. After some time, I will stop these statements. Both are simple support. Therefore, both supports, they will be only vertical reaction. Let VA upward direction and VB upward direction be vertical reactions at the support A and B respectively as shown. Put a sketch here. This is actually a very simple question, but I told I am always solving systematically. No question of confusion, nothing. Those who study everything, they will have no problem. Load is 80 kilonewton. 80 kilonewton. This span is 6 meter. Started raining. See, this is 3 meter. Okay, now I will do one thing. Solution now. See, rain started a little more. If it becomes the furthermore, I will stop. I will pause because rain sound will come. Light round is okay because above the classroom there is sheets here. Okay, now First do one thing. First you do traditional solution. That is by using equilibrium conditions. Okay, start. Sigma m about a equal to 0, take clockwise positive. Algebraic sum of moment about the point a equal to 0, Va into 0, Vb into 6 anti-clockwise minus Vb into 6 is, I am not using color now for this, okay, color minus Vb into 6 anti-clockwise plus 80 into 3 equal to 0. Take this one that side, be little careful, there's a minus here and plus here. When minus something and plus something is 0, this minus will become plus that side. That much common sense is required. If that much is not known, better not study structural engineering. Therefore, sometime I have seen people, they will write, therefore, minus Vb into 6 plus 80 into 3, they will write 240 equal to 0, or minus 6 Vb equal to minus 240, or Vb equal to minus 240, or minus 6 what? It's a primary school class. Therefore, your Vb will come plus 40 kilonewton. Then, sigma V equal to 0, I will take upward positive. What you get? Plus Va plus Vb minus 80 equal to 0. Next time I will write here, see, I will tell Vb is known, substitute that Vb, get Va, but right now I will write substituting Vb equal to plus 40 kilonewton, we get plus Va plus this Vb bracket plus 40 minus 80 equal to 0. Therefore, Va equal to plus 40 minus 80 is minus 40. Take that side, it becomes plus 40 kilonewton over. Therefore, right here. Therefore, you write a sketch here. Write the beam once again. Therefore, for the given beam, support reactions are as shown below. See, 80 kilonewton load. This is systematic solution. Span 6 meter. This is A, this is B, this is 3 meter. This reaction Va equal to 40 kilonewton. This reaction Vb also equal to 40 kilonewton is the final answer. Now make a note of all this one. Just make a note. Or, see, this sketch you are right. After this sketch, you make a note here. Or we can use symmetry right here. Due to symmetry, there is after some time in short form, I will write DTS. When I write DTS, you should not write DTS. You are learning, I am teaching. I will write DTS. Sometimes some student will ask, he may not see all the classes. What is DTS? I will tell something at them. Do not, what I can tell. My class, don't come to my class, something like that I will tell. My class is not for you. I will think of something for DTS. If a comment comes, sir, the DTS is not clear, I will tell immediately. I will use the word D, T and S and write there. Meaning will come. You stop attending my classes, or you have got too much of knowledge. Go to a better person and learn from him. My class is not suitable for you. I should be very harsh in such matter. I told short form to save time, DTS, right here. Directly, see, this sketch you are right. Vertical reaction at A in upward direction equal to vertical reaction at B in upward direction equal to total load on beam in what direction? In downward direction divided by 2 equal to what total? There's only one load is there, 80 divided by 2 equal to 40 kilonewton. Then you make this entry final reaction. This is simply supported beam with central point load, one bookwork of W and L, one numerical value. Okay, now Question number 3. I will put question number 3. Very, very powerful question. See. Question 3 is very, very important question. I am not passing. I am writing now only. Because if I pass, it will take some time. Okay. Very powerful question. Question 3. This way. Question 3. And for that question, round off, round off, round off. This is very, 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 very important. I will tell you why. Reason, little right here. Reason, little later. I will first dictate the question. Okay, I'll write the question here. A simply supported beam of span L is subjected to a concentrated load of magnitude W at A from left end or at B from right end, so that A plus B equal to L, right end. Right. Question is, find support reactions and if you realize, you means me, right now me, if you realize some important concept, clearly write it. Okay, over. Start question. Simply supported beam AB span L. See, load W. Now, doubt comes whether load is this side or that side. It does not matter. Close your eyes. Okay, I have closed my eyes. I'll put the load here. Anywhere. W. Don't by heart. See, now this distance is A. I'll put upper side. See, okay. Now I write this is A or this is B. So surely you can write here A plus B equal to L. By chance in any question, if they give only A in place of B, you have to write L minus A. I will give the result for you. Okay, start. Now, you put this beam. Now, write statement. Beam is simply supported. So, only vertical reaction, let VA and VB both assumed to be upward, be vertical reactions at A and B respectively as shown. I will remove this one now. I will show the B. See. This is the beam. Some load W. From here is A. From here is B. Span is L. This is A. This is B. This is VA. This is VB. Okay. Now there is no symmetry. Now you can't make divide by 2. Start. Apply. Sigma M about A equal to 0. Take clockwise positive. What all I am writing, correctly observe. See, sometime concept will come if you start observing, not simply by hurting. Okay. Take moment about A. Finger should be here. Minus VB into L. Somebody may ask me, sir, why minus VB? No, don't come to my class. That's all. That's the comment I will pass. Minus VB into L. After so much explanation, if someone will ask, sir, why minus means I to clockwise positive, minus VB into L plus W into A equal to 0. Therefore, your VB will be equal to, see, minus VB into L plus this you can take other side, that much. Primary school mathematics, it will come plus W into A divided by L will come. Okay. Now, sigma V0 take upward positive. You get plus VA plus VB minus W equal to 0. Be careful. Therefore, now substitute VB equal to what you got there, plus WA by L. Substitute that answer. You get plus VA. Then this plus is not that plus. This plus is sigma V0 plus bracket, right, plus WA by L. It is known value now. Okay. WA by L minus W equal to 0. Therefore, your VA will become, see, this minus W, that side becomes plus W. This will become minus WA by L. See, this is full W. This is part of W. Why? Because A is less than L. If this is 100 kilonewton, this is surely less than 100 kilonewton, or equal to PB equal to W into bracket 1 minus A by L, or equal to plus is not required now, W into, you take L common. If you take L common, it is L minus A by L. L minus A by L. Therefore, make a note now, a very important note. Right now, make it. Therefore, you stop there. You tell, I will come later. I will come later. I'll stop there. Therefore, in question, if only A given, that is, if the question is a simply supported beam of span L is loaded by a point load W at distance A, nth of A, anything they can tell, yes or A from left hand. See, that is, if the question given is only like this, see, they will tell span L, a load W at A from left hand. Then, see, then the reactions are, see, this is W, this is A, this is L. This reaction VA equal to W into L minus A divided by L. This is reaction VA. This reaction VB equal to W into A by L. Remember this one is the answer. But someone will tell me, now once again come back here, or you can do one thing. You write this much. Write this note afterwards. Okay, now write. But we know that L minus A equal to B. See here, L minus A equal to B. Therefore, your VA will come W into L minus A is W into B by L. B by L. Here also see, L minus A is B only, B by L. This result. Now write the result correctly. See, now write result. Therefore, for the beam simply supported at both ends, if you apply a load W, it will down only, because very important, powerful. If you apply a load W at A from here, span is L. If that is A and if this is B, then this reaction VA equal to W into B by L. This reaction VA equal to, this is VA, this is VB equal to W into A by L. This is the answer for this beam. Now, correctly observe, right here. Correctly observe. If the load W, you should, what all I tell you are right here now. As I told, notes I will write. If the load is W is at A from here and B from here, you see everywhere W is there, L is there. Here B by L, there A by L. Or this load is, the reactions will be inversely proportional to other distance. Right here, other distance. Or simple language, I will tell why other distance. See, if the load is very closer to A, this reaction comes more, that length is more. If the load comes very closer to B, this length is more. So for VA, we got WB by L. For VA, we got WA by L. Or you write here, you can write this in words. In words. In words. In words. Words will be common words for both. Common for both. Common for both VA and VB. It is common for both VA and VB. But remember, for simply supported beam with only vertical loading and one point load, that is any reaction, vertical reaction, okay, that is vertical reaction at any support equal to load multiplied by distance of I want new color or very dark I want right now. Okay, right in the right time, not getting the other time. Okay, I had to make it a little dark now. Distance of other support from load divided by length span or length. Load into, okay, span is a black color. Span is not, that is red, divided by span or length. Span, that is L. Load is W. Okay. So whether you want VA or VB, see here, VA equal to load W into, if you want reaction here, it will be based on other. See, for VA, if I tell A here and B here, this is C. This reaction equal to W into other. Other is B. Other is B divided by L. This reaction is load W into other side, A divided by L. Or instead of this much wasting time, you can write simply any reaction equal to load into, remember, other distance by span L. Okay, now this is the result we got. I will discuss on this one little more in the next class because more discussions are there. This is very, very powerful. Now see, now I will give one final conclusion answer here. Full board I will write. Up to end of your study you have to remember it now. Or see here. There is some problem here because that one cloth I am using for rubbing, that is not available here. I don't know what happened to it. Therefore, make a note here. If a simply supported, I have to wait for a little time because it is very wet. If it is wet means difficulty for writing. It should become dry. Okay, these are all minor parts. That is final summary. So now go for very, very, very important concept. Remember, simply supported beam with and it is called eccentric. See, central point load means, you can make a note here. What you are discussing is eccentric point load. I forgot to write. You write a note in the beginning only write. When I start question 3, you write. Heading you can write simply supported beam of span L subjected to eccentric concentrated load. Eccentric concentrated load. Concentrated load. Now write here. In case, see, suppose your question is, you make a note what all I tell you right here. If the question is simply supported beam of span L subjected to a load W at A from left end or B from right end, surely your A plus B equal to L. Here A is, if you write everything, A is distance of the load from left support. B is distance of load from right support. Now, then directly you can do one thing. This reaction VA, this reaction VB equal to equal. Okay. Or, right here, or. Suppose in the question it is given simply supported beam of span L subjected to a load W at A from left end over, that's all. B is not given, no problem. Then this reaction VA equal to this reaction VB equal to. Remember now, for both of them common is any reaction equal to load, that is W into, I told simple form, other distance. This is a short form, other distance by L, by span L. Span L. Technically you have to write distance of the other support from the load, or if I want reaction VA here, load W, see, if I want here load W into, if I want here other, that side B, W into B by L, this reaction is W into other distance A by L. Remember, inversely proportional, not directly. And here, if they want this reaction, it is W into other distance, not given. So if this is A, this will be L minus A, dark L minus A by L. This will be W into other is A by L. Make a note. Now don't tell me, sir, exam question they told A from right end. If they tell A from right end, this will become B, then this will become W into, you can interchange, that I will tell you later. So this is the final summary. I will tell this is very useful for you in so many ways. How useful, I will show by example, subsequent question solve. Every question, when I solve here, I will go to shortcut there. This principle. But remember, only for vertical loading and no couple, just for one vertical loading. Study thoroughly everything, get ready for next class will be question number 4. Question number 4. Okay, start. Now start. After I explain, I will tell, okay, start. Now what not, okay, start. Now end the class. Thank you. And start learning and go through everything.